Morning grade sixes, and welcome to your mathematics lesson today, brought to you by WorksheetCloud.com. I hope you guys are all well. Just a reminder of the email address on your screen. Please feel free to use it at any time and email me any questions regarding any mathematics that you might have. Today we're going to be looking at symmetry, and more specifically reflective symmetry or line symmetry. And then on either side of that, we've got our normal warm-ups, mental questions, and finishes. Okay, so your warm-up for today is to find out the value of that construction, those construction symbols, and then the question mark at the end. Right, off you go. So I did this via trial and error. The numbers I have on the screen at the moment aren't the ones I originally started with. I think I originally started with 8, 8, and 3. And then when I used 8, 8, and 3 going through the puzzle, it didn't work, so I had to start again. And that led me to 7 plus 7 is 14 for the trucks, plus 4 for the crane. That works, that gives me 18. And then I went on and I said that I needed to add something to 7 to get me 33. And that would have been 26. So the ships, I would have said, with 13 plus 13 is 26. Add the 7 is 33. Then the crane was 4. So double crane must be 8. And double ship must be 26. And that gives me 38. So that worked out. And then double truck was 14. Multiplied by double crane was 8. Multiplied by double ship was 26. Okay, and there would have been a trickier question to work out, but remember, go in steps. So I personally would have gone 14 times 8 first, 10 times 8, 80, 4 times 8, 32, so 112, and then I would have gone 112 times 26. Okay, and then you could use any multiple methods, doubling and halving. 224 times 13 makes it perhaps slightly easier. 224 times 10 plus 224 times 3. Add them together and you should get 2,912. Okay, so that is your final answer at the bottom. So I think the most difficult part there is possibly multiplying those three numbers together at the bottom. As I say, you could have gone 26 times 8 first and then multiplied the 14. The choice is yours to make. Okay. Then your mental maths questions for today. First question, you're looking for a better bar, so A or B. Question 2, division. When I'm dividing by 8, my answer is 6 and 3/8. So what is the dividend? What am I dividing? Then question 3, can you use 243 multiplied by 15 equals 3,645? Can you use that number statement to tell me the answer of A and B without actually working A and B out? There is a question number 4, detailing, looking at ratios, scales on a map, and then a long division question at the end, which I'm interested to see how you guys get on. Right, off you go. One, which is a better bar, A or B, and by how much? So something that you come into contact with quite often when you go shopping. Anyway, 8 250 gram packs of knickknacks at 45 cents or 2 kilograms of knickknacks at R1.60 per kilo. So we work out option A first. And option A, we've got 8 packs of knickknacks at 45 cents each. Okay, and to work that out, you could have gone 8 times 40 is 320 plus 8 times 5 is 360. So that's going to give me R3.60. Okay. Yes, you could have done doubling and halving. You could have halved 8 to 4, doubled 45 to 90. Then 4 times 90 is also 360. And then option B is 2 kilograms of knickknacks at R1.60 per kilo. So that would be 2 multiplied by R1.60. And that's going to give me R3.20. Okay, so there you can see that option B is going to be cheaper, and it's going to be cheaper by 40 cents. Okay, Cool. And you needed to look at 243 times 15 equals 3,645. And notice that in A, I've divided 243 by 100 to get 2,43. So that means my answer is divided by 100. So 2,43 times 15 is equal to 36,45. Okay, I don't actually have to go and work it out. I can just see from 243 times 15 equals 3,645 that I've divided 243 by 100, so I must divide the answer by 100. And in B, I can see I've divided 243 by 10 to get 24,3, and I've divided 15 also by 10 to get 1,5, so 10 times 10 is 100, so I need to divide 3,645 by 100, or by 10 twice to get 36,45. Okay. Question 4 is looking at scales on a map. So if 9 centimeters is flown by an airplane, and on the map 1 millimeters equals 50 kilometers. They want to know, what does 9 centimeters, how far, how much distance is 9 centimeters? So the first thing I need to do is convert the 9 centimeters into millimeters, and that's 90 millimeters. So now I must just multiply the 50 by the 90, and I get 4,500 kilometers. Okay. And then your last question, and I will work this out in the two ways that I'm thinking about, is 672 divided by 42. Both the dividend and the divisor are even, so I'm going to halve them both. Okay, so that's going to be 336 divided by 21. Okay, and then I can work that out. I can say 21 times 10 equals 210. Okay, I can recognize that 21 times 20 is going to be too much, because that's going to be 420. So I'll times by 5, that's 105. If I add them, I get 315. Now I can see that from 315, I still need to add one group of 26 to get to 336. And if I have a look, I've got 21 times 15 to get to 315. And I must add that extra group, so that's going to equal 16. If you had left it at 672 divided by 42, then you could have gone 42 times 10 equals 420. I would have gone by 5, because I would have noticed that to multiply by 20 would have been too much. Okay, 630, I can recognize that I need to add one more group of 42 to get to 672. So if I look, 42 times 15, it gives me 630, plus the additional group of 42, and that also equals 16. Apologies that I'm overlapping there. So both ways it would have given you an answer of 16. So I'm working division out by multiplying, and I'm doing some pretty straightforward multiplication sums. I think I left out number 2, if my memory serves me correctly. If I did, I apologize. And if I didn't leave it out and I'm going to do it again, then I apologize again. But I'd rather do it twice than not do it at all. So if a number divided by 8 is 6 3/8, so this is what they're saying. Always good to write it down so you can get a visual idea of what they're talking about. So I'm just going to work backwards and go 6 3/8, which is 51 over 8 times 8. They cancel out, and my answer is 51. Okay. So 51 belongs in there. All right. Okay, I think I've covered all of them. Let's go back to the main theme of the day. Right, so today we're going to be having a look at reflection. And the first thing I wanted to show you was just a little bit of reflection in real life, or things that people have, artwork that people have created. So there you can see a little bit of symmetry in those shapes. There you can see some symmetry in nature. Okay, so you know, the most common one, or the one that we speak about the most, is either reflection in water, of which you've got a few examples there, or you can see the butterfly is the other one that's a really common one to talk about. And you can see, especially the butterfly that's opening up, how the two halves are symmetrical. So when we say things are symmetrical, if we can fold them in half, either vertically or horizontally, and the one half, or diagonally, and the one half fits on top of the other one, then we know that they are perfectly symmetrical. Okay, so some examples of symmetry for you. There's also symmetry in music. So those of you who are musicians having a watch, perhaps you've seen symmetry in music before. And then there's also man-made symmetry. So you get a lot of symmetry in architecture. You know, you've got different monuments around the world that have architecture that has symmetry that dates back hundreds and hundreds of years. So it's not a new concept. But yeah, I just thought I'd show you those to give you an idea of exactly what we're talking about. Okay, so some objects only have one line of symmetry, and there are a few sound effects in this presentation, so apologies about that if they get annoying. So that has a vertical line of symmetry. All right, so vertically top to bottom, and that middle piece has horizontal lines of symmetry. So if you fold those shapes along those lines, the one half will fold along the other, and then those are diagonal lines of symmetry. Okay, some shapes have two lines of symmetry. So a rectangle has two, and we'll get to, if you thought there were four there, I'll get onto that soon. Okay, there is another two lines of symmetry. So some are vertical and horizontal, some are just two diagonal lines. Okay, but it's very possible for objects to have more than one line of symmetry. So here's the rectangle problem. Many students think that a rectangle has four lines of symmetry because a square does, but a square is a regular shape. And we'll get on to just now the difference between regular and irregular. Remember, a regular shape, all sides and all angles are equal. And in a rectangle, only opposite sides are equal. So it only has two lines of symmetry for a rectangle and four for a square. Okay, so if I can prove it to you, if you imagine half a rectangle, okay, and that was our diagonal mirror line. If I covered it with some tracing paper that's going over now, and I took my pencil and I drew over the half a rectangle, and then I turned my tracing paper over, you can see that the other half does not fit perfectly onto the half a rectangle to make a full rectangle. It creates a cut. Right, so here are the regular polygons I was talking about. So three-sided triangle, four-sided square, five-sided pentagon, six-sided hexagon, eight-sided octagon. And sounds like a spy code coming through a typewriter on an ancient World War II movie. Regular polygons have lines of symmetry equal to the number of sides or angles that they possess. So basically what that means, in a regular polygon where all sides and all angles are equal, the number of lines of symmetry equals the number of sides. So that's got 3, That's got 4. That's got 5. And you can see the other ones have got 6 and 8 respectively. Okay, so that's something worth remembering moving forward. Okay, so we get on to reflections. Okay, and how do we do reflections? How do they work if we get asked? And I thought it's quite a difficult concept to show you without actually being in front of you with a piece of paper and a tracing paper and a pencil and a ruler, but hopefully this gets my message across. So the mirror line is also the line of symmetry, so that this mirror line on this picture represents the dotted line that you would have seen in the images before. And if they give us that object, what you need to do is you either use tracing paper, or if you have a mirror, you can use a mirror, but not everyone carries a spare mirror in their blazer pocket, and I don't blame you. So you can use tracing paper to trace over the object. There's your pencil. Okay, and also trace over the mirror line. So you can see there's a blue line indicating the mirror line, and then you just need to fold your tracing paper over the mirror line so that it ends up like that. Mark off the vertices. Remember, vertices are corners. Take the tracing paper away and join the shape up, and now you've got the image, which is an exact reflection of the object. It's really important that you notice that the image is the same distance away from the mirror line as the original object. Okay, that's hugely important. So if we did another one, there's your mirror line. The object is a kite. Take your tracing paper, you trace over it with your pencil, and make sure you use a ruler so you can ensure that you are 100% accurate. Okay, and then you draw your mirror line, and you have to turn your tracing paper over so that the mirror lines match, and you can mark off your vertices of your image, take the tracing paper away, and join the dots, and your image is an exact reflection of your object. Okay, so these are obviously really basic shapes, but it's just to give you the idea. Sometimes, as I showed you, reflective symmetry images in nature, they can be quite complex. So yeah, it's always good to get a good idea of a basic image before we move on to more complex things. Okay, and then I think this is the last one where we just look at a diagonal reflection. Okay, but the same thing applies. Use your tracing paper, draw over the object. Okay, draw over the mirror line, fold the object or fold the tracing paper over the mirror line, so diagonally, and then your tracing paper will end up in that position. Mark off the vertices, remove the tracing paper, join the dots, and there your image is a reflection of your object. Okay, so guys, you can have a look at this brain bender in the meantime, but that's reflective symmetry in a nutshell. Your online activity I left for you today was to practice some reflective symmetry. So go have a look at that. I've also left the memos there for you, so you can have a look at your reflective symmetry, whether it's correct or incorrect. And I just want to encourage you to use a ruler, use a pencil in case you need to rub out, and try and be as accurate as possible. So a sharp pencil really goes a long way to ensuring accuracy. Really simple tip, but it can make a massive difference at the end of the day. Okay, your magic squares in front of you. No number can be repeated in a square. Your rows, columns, and diagonals must add up to the same number. I'd like you to tell me which is the magic number for each square. So I know these lessons are pre-recorded, but I actually haven't worked out the answers for this, so I'm going to see if I can do it live. So the first thing I'm looking at is 9 plus 2 plus 10. That's going to give me 21. So now I know all columns, rows, and diagonals must add up to 21. So I'm saying that's going to be 7. Then 9, 7 is 16. That's going to be 5. that'll be 6, that'll be 4, 9 and 3, 9 and 4 is 13, that'll be 8. So remember, no number can repeat. And if I make a mistake and I don't pick it up, please feel free to email me and say, hey, you made a mistake. That's also fine for you to do. First thing I'm going to do is in this column here, I'm going to have a look at 14, 5, and 8. I think that gives me 27. Okay, so the bottom row, I've got 12, so I must add 15. Diagonally, I've got 18, so I need to add 9. 15 and 9 is 24, so I must add the 3. 14 and 3 is 17, so I must add the 10. If I check diagonally, 10, 9, 19, 8, 27, cool. And all I'm left with here is 13. Okay, and then that last one, that's going to equal 24. So I'm looking at 8 here. I'm looking at 4, 9, 7, and 5. Okay. Okay, so that's your magic squares. They can increase in size to 4 by 4 or 5 by 5, so they get a little bit trickier, similar to your can-can puzzle or a Sudoku puzzle. Not exactly the same, but it's good to try these different games out and to keep your brain fresh and active and to keep challenging it. Okay, guys, then there's your 24 activity for the day. Use all the numbers on each card, any operational signs, and try to come up with 24 and see how many different ways you can come up with 24. That's a little challenge for you to do in your own time. And then grade 6s, thanks very much for joining us today. I hope you learned something about reflective symmetry. Have a great second long weekend, and we'll see you next week. All the best.